All right. Hi, everyone. I'm Brenne. Let me go ahead and start sharing my screen. Find the right one. There we go. All right. So I'll be giving you the Astrid portion of this talk, and then Amber will follow with Cleo. So Astrid, you go ahead and open via your terminal, and you just go ahead and type Astrid in. And Astrid is how we interact with the telescope. So it stands for Astronomer's Integrated Desktop, and it'll take a couple of seconds to open, but you'll get this lovely splash screen. And this is how we as observers can interact with the telescope and watch everything that's happening.
Are we supposed to have access to this yet?
Will?
Because I don't think we got our FastX logins yet.
Nope. So I will send you those here after lunch, and then there will be like a connection workshop. So this is more just the show and tell, and then you'll have the experiential portion of it later. Thanks for asking, though.
All right, thanks.
Yep.
So when you open Astrid, it's going to ask you for real-time mode. So you have three options. Your first option is to work offline. This is great if you're just editing scripts, making sure that everything's ready for your observation. You have work online, but only monitor observations. So this, you're able to see sort of what is going on with the telescope and all of the stuff going on with that. And then you have work online with control of the telescope. And this is known as being in the gateway. So you're only using this option once the operator has told you that you're clear to start your observations. So you'll go ahead and choose one of those. I currently have another one open that we're gonna use first. So we'll start with our observation management tab. So you can manipulate this window any way you'd like, just like any other window. I will warn you, some of these drop downs are a bit hard to grab, and it may take you a little bit to get those, but just kind of stick with it. And you can go ahead and access your project from here. So you have here in this edit sub tab under observation management, you have your project. So you go ahead and you click that little button, and then all of your accepted projects will have a code under AGBT. And so you can go ahead and click underneath there and then scroll down to where your code would be. So say your project is this semester, it would be AGBT 21A. You would go ahead and click that other sub button, and then you would find your full code here.
And so when you're doing that, you also want to make sure that you click on the arrow. If you just click on the name, it's not going to give you the drop down. It's going to take you to an empty file that doesn't exist.
Or it'll do this.
Random things.
What you
so
want.
Make sure you use you click on the little arrows and not just the name. Sorry, Brenne, go ahead.
Oh, sure. So I'm going to scroll. I'm going to close all that first of all. And then I'm going to use a different code so that we can look at a script that we have. TGBT, that's the wrong one. And as you can see, there's quite a few codes, so you're gonna have to scroll for a little bit. You can put your scheduling block in here. You'll see right here you have an editor. So right here I'm currently editing nothing, but that's where you can type in your script. You can directly type into this window, or you can import a script from a file using exec file command, which if you want to use that, you can go over with your project friend for the observations this afternoon. So I'll go ahead and click this observation. So this is just a sort of a standard hydrogen observation block. You have your config file in there, and this is what is known as a scheduling block or a script. People will use those sort of interchangeably. And so you have this button here. So once you've written your script, you're pretty sure it's correct, but you're not 100% sure, you can go ahead and use this validate button, which will go ahead and it will go through the script and check the script for syntax. So if you've missed a comma somewhere, if you've missed something like that, it will check that. It's important to note that it doesn't fully check what you want scientifically. Talk to your project friend for that, but it can do small things like if you've named a source and down here and it's not in the catalog you've said, it will let you know that it's not there. This is very important. It's happened to me a couple times. Your changes do not take effect until you click Save to Database. So imagine you're observing, you got to change something on the fly. You click Validate, you go to submit your script. It's still going to be that previous script. So it's important that you click Save to Database.
And when you click Save to Database, it validates automatically in the background. So if you save, you also are doing the validate. You can tell by the stoplight. If the stoplight's green, you're fine. If it's yellow, that means you haven't validated. And if it's red, that means there's an error. It's a little stoplight that's down there in the one corner.
So I'm going to go ahead and save to database. And so it'll pop up asking you to enter a name for your scheduling block. If you want to just edit a scheduling block, just save it as the same name. But if you want a completely new scheduling block, go ahead and change that name and you can press OK. So I'll press cancel there for right now. And yeah, again, just like Amber said, this green means it's validated. Say if I change this and I try to validate it, I'll get a red, and then it will tell you what's going on in your script and where that problem can be. Some of them, the errors might be a little bit difficult to figure out, but just go through your script line by line or the line that it states and it'll let you know. So then you go ahead and just fix that. Again, you've changed it so it's yellow. You go ahead and validate slowly but surely.
So the other thing I'll point out as well is that, so Brenne is in offline mode. When you validate, you'll see there's a warning there that says you are using a simulated telescope. When you validate in offline mode, it's going to automatically assume that the telescope is in perfect condition and that every single device on the telescope works. That's not entirely true, and in most cases wouldn't be. So if you do it in online without control, it will take into account if one of the optical drivers are down or something, and it will tell you. So I usually suggest that once you've done it here, once you've done it offline and you've written your script and everything, then go into the online mode and validate just to make sure that nothing has happened, nothing has changed since you wrote that script. Like one of the optical drivers went out and it needs, you need to reroute or something like that. So go ahead.
It's always a good double check.
Can I interject with a question? Someone asked, do we have to write the script from scratch, or once our proposal is approved, will we automatically get one with the setup we requested?
So most of the time you will be writing your script, but if you contact your project friend, they may know if somebody's done a project similar so that you can see an example script. I know with pulsars, a lot of times if you contact your project friend, they'll be able to give you an example script pretty easily because a lot of stuff doesn't change.
Yeah, in most cases we'll find there'll be a script that exists. And as you can see, the ones Brenne's actually using are ones that her and I are working on for different scenarios that are actually essentially templated scripts that you guys are always welcome to use as your backbone. Most people do not write they write their first script, but a lot of times once they've been doing it long enough, they just copy old scripts and alter everything. So yeah, and your project friend will help you with that.
So if your script fails to validate, you can check through there. And it is always good to double check with your project friend if you're not sure about something, especially science-wise, because this is just syntax. You can delete from database. I'd be very careful about this button, especially if you're looking at old scripts, but you can also import from a file or export to a file.
So I guess something else that also might be useful to say is that this is not like a locked device. Like none of these project scripts are locked. So you do have access to other people's scripts, which means if you delete them, if you save over them, if you do something to someone else's script, you have affected their actual script and there is no backup for that. So please don't go through. You're more than welcome to go through and copy a script, but do not alter a script or anything like that because you are actually altering it in real time. This is the honor system. So essentially we're saying don't mess with other people's scripts because you can actually do that.
Yeah. And then, so we've been underneath the observation management tab, and if you go into online mode, let me switch windows. Try to move this around a little bit. Work online, but only monitor. You can see down here we have this log that's the observation management log. So this gives you updates on what the status of the telescope is. It'll be blank if you're in offline mode. You just saw it was blank because you're not connected to the system. So what shows up is giving you information related to how the scheduling block has been run. So it'll let you know if it's started, it'll let you know it's slewing, it'll let you know if it's balancing the IF rack, and all of that good stuff. It can say, it can print out any print statements that if you have in your scheduling block, say you want to check bandpass levels or something, it'll print there to let you know. It's really good to be watching this as you're observing. It's because it is letting you know what's going on with the telescope. But if you want to export this log after you finished observing, if something went wrong or you just want a copy for your records, you can go ahead and export that. And then, let's see, go back over here. So next we have this run tab. So I'll go ahead over here. Underneath this run tab, this is where if you're online and in control of the telescope, you're going to go ahead and submit your script through there. So again, you go down to your project, you can type in your project code or you can just drop down. You would choose your session for your project. So if you're scheduled for your 4th session, this should be 4 to match. You will then click observer. So click down here and there are quite a few names. If your name starts with anything past B, I would recommend you start typing instead of scrolling because you'll be there all day. So there I have me, and then you choose the operator. So when you go into talk and draw, which Amber will talk about a little bit later, you let the operator know who it is, what you're going to be observing for, and then you'll choose the operator, whoever tells you they're operating. So you just choose that. Let me go ahead down to test so you can see what this will look like. 20A. So all of your scheduling blocks will pop up here. You go ahead and you choose whichever block you want to submit first. And then when you're on online mode and control the gateway, you would just click submit. And then you'll see that pop up over here in the session history. So you can also run you can put multiple scripts in a queue. So you just put it in the run queue and you can move scripts up, you can move them down, or you can remove. So if you accidentally put in a script, it's not set in stone, you can go ahead and remove that. So let's see. On the side, one second, I've got to move everybody's faces. On the side, you have these buttons called observation state, Gbt state, Gbt status, and then down here. So I'll get to the observation states in a second, but these buttons are related to you running your project. So you have your queue control, so you can halt the queue if you want the scripts to stop, but you have observation control. So pause here, it stops the execution of a scheduling block at the end of the next line of code. So say you have a bunch of on-offs that are in a row, you can go ahead and press pause and it will pause at the end of that line of code. It's not very helpful if you are, say, observing a pulsar and your track command is a very long track command because it will wait till the end of that and you're at the end of your scheduling block. So stops the scan at the end of the next integration time. Abort aborts the scan immediately. So if you're observing and the operator says something's going wrong and need you to abort, that's the one you click abort immediately. And then again, you're always listening to the operator for however you're interacting with the telescope. It can sometimes lead to corrupted data, but don't worry too much. It's just the last integration. So it's not a big deal if you do have to click abort. And then you have the interactive option, which will automatically select the best option for the telescope if you need to leave the room after letting the operator know you need to leave the room, and you have prompts in your script. And by best option, it's safest for the telescope. So let's see. So that's sort of been the observation management tab and everything you need to know about running that portion of Astrid. So then over here we have the data display tab. So again, these are all observations for those. These were all observations for those guides that Amber was talking about that we have out and we'll have out for people. But this will only give you information on what's currently being observed if you're on online mode. If you're in offline mode, you can go look at previous observations to see some of the data here. And then the scans can be viewed on the side. So here you can see we had, during this observation, there was a peak in focus and it was consisted of off-ons and on-offs. So you'll be able to see that here. Pulsar data cannot be viewed besides if you do a pointing focus in here, and neither can mapping data most of the time. So it's continuum, spectral line, OOF, and focus and pointing. So we'll go through those. Pointing, as you can see here, so that's should be your initial check for making sure that the GBT is pointing accurately. And so here you see this green line. And if you could look very closely, you can see that sort of red line underneath. It's going to try and fit the red is the data you're getting, and it's going to try to fit that red line with the green line. So if it doesn't look great, it will look very different from this. I don't currently have an example of that, but it'll be pretty obvious. The red will be pretty much all like that. And it will automatically give you pointing corrections. So down here, you can see the old as and the old L, the change, and then the new. So you see 4 plots, again, for the Gaussian plots, and it's slewing over azimuth and elevation. These will look slightly different depending on the receiver that you're using. So this one was the L-band receiver and has 1 beam. And the beam of the GBT is very closely Gaussian. So it's approximating that fit, and that's how we're able to get a rough pointing direction and adjust to that fit. But you have a couple of options. 1 second, let me move faces again. There we go. So you have a couple options when it comes to your pointing data. So you would go to Tools under Data Display and under the Pointing tab. This is pretty finicky, so if you are in any other tab, you won't be getting the tool options for this sub-tab. So if you're underneath data display pointing, you go to Tools, Options, and you'll see a bunch of different pointing options. So for example, if the green-red fits aren't looking great and you want to change, you can go ahead and choose different options. It is automatically accept good fits and automatically reject good fits, but you can choose a different one depending on what you want. If you choose to not apply corrections, you can go in and physically put in and send corrections. So say the ones down here, you would just type them in, press send, and press OK. So if you want the fitting criteria to be different, you would go to the heuristics tab, and that's sort of the term we use to quantify the goodness of fit. So standard will take any full length half max within 30% of the expected values, and relaxed will take within 50%. You typically would go to relaxed if you're observing at high frequency. So if I think it's over 40 or 50 gigahertz, you want to start using relaxed. Or say your weather's particularly bad, but you would just go ahead and click which one you want, press OK, and then those will send. Okay, so let me see, go back in there.
Brenne, there are a couple questions in here. So one is it attempting to fit the green line by adjusting the actuators or the position of the subreflector or some physical change to the system?
So it's changing the azimuth and elevation. Yeah.
So at the end of this 4-panel scan, it will basically suggest a new, not a new pointing model, but a 0 point for the telescope. So it will automatically accept good corrections there. So it's not doing any changes to the system throughout there. And then another question is, does this mean we have to actually find a peak source for observation block that we plan?
So we do have a catalog. So if you use, depending on which receiver you're using, you would use auto peak focus. And then if you leave the parentheses blank for that, we have catalogs that will choose based on the receiver that you're using. So you would use the Flux catalog. So
it's also good to note that, as Brenne said, this is correcting for the as and L. So you want to make sure that when you do these, that you're actually pointed to an area that is close to your source. So I usually suggest that, you do all your stuff, your, configuring and everything, and then slew to your source. And then from there, do the auto P focus, like Brenne said, leave it blank, and then it will find a source close to your source, close to whatever your target is. Because if you're moving too much, the problem is that the track's not level. I mean, it's the ground. It can't. There's no way for it to be perfect, and temperatures and everything affect it. So you want to make sure that it's adjusting for the position it is at currently, and not like you don't want to do it first and then slew to your source, which might be half a sky distance away. So want to make sure you're close by, and then leave it blank, like Brenne said, and it will automatically find one for you, or you can choose your own
if you so choose.
Yeah.
So also in here, you're able to see the data processing, and this will change depending on what receiver you're using, but total power, raw, polarization, X, Y, both. So you have a whole bunch of options in here if you need to change anything. So next we will go to our focus tab. So this isn't a great focus, but this is for the subreflector. So normally you'll see the green line here matching with that focus. And again, you can go into tools, options, all of your options, but here your send corrections will be focus corrections.
Brenne, is that your actual point focus for that?
This was
Click on the focus scan there.
Yeah, I don't think it was.
Yeah, click on number 5 there, so it should populate with that. Oh, maybe it was.
So typically it will look a lot better than this, and you'll see that green line.
Yeah.
But all right, so moving on to, we have our OOF tab. So if you're doing high frequency and you're doing the OOF like Dave was talking about, this is where you'll kind of deal with that. So it'll take your scans and then it chooses the 5th Zernike solution as a default. And it's looking at the dish and adjusting the actuators for any kind of large scale thermal deformations or for more accurate data. And again, it's mostly high frequency. And I believe there's going to be another lecture talking more about high frequency, so we'll go probably more in depth with that. But this will send corrections to the telescope. So you also have Continuum and Spectral line tabs. So here's your Continuum tab. The best practice when you're working with Spectral line is to open Gbt IDL and look at your data through that as you're observing too, because that will allow you to do on-offs and actually look at the data, because this doesn't process it as that does. But if you have different polarizations, you can go ahead and click them on the side. Say you have different beams, click that. You can look at your different phases. So your signal no-cal, signal cal, and then frequencies if you're observing with a receiver that looks at different frequencies. And so you can, on the bottom, I'm going to see if I can do this, probably not. As you can see, my mouse is kind of moving around like there. If you can grab and drag at the bottom of some of these plots, it can show you that the x-axis can be in channels or frequency for some of the plots.
It's like a skill. You have to have done it like a bazillion times in order to do it, like every time. And even then.
There we go.
You go, she got it.
So this one doesn't have that, but yeah, you can see how difficult that can be sometimes. And then you have your spectral line, which doesn't have anything here right now.
You can click on your on-off scans. It should show you spectral line then. Okay. Oh, wait.
So that's not handled in the plugin, but typically it will show you your spectral lines. And then we'll go to our last tab here. So this, again, this was all underneath the data display. So you have all of those tabs underneath data display. And then you have your Gbt Status tab. So Cleo has a wonderful window that has most of this information, and it's nicely color coded and everything. But this one is, if you're in Astrid and want to quickly check, it will tell you the observer, it will tell you your project ID, the status of the telescope, it will tell you your last update, time, and everything. So that's good to check that that's all correct. Then you have where you've commanded the telescope to go, where it actually is, and all of that information. So if you're working through your observation and you want to double check that everything's correct, that you're sending the telescope to the right spot, and you don't have Cleo open, you can go ahead and use that. So make sure you're always checking that, because you never know what happens with catalogs and stuff like that. It will tell you what scan you're on. It will tell you the duration of that scan. It will tell you the start time, how much time is left in that scan, if you're on source. And this is a lot of this stuff is all defined in your configuration file. So it'll tell you your source, your velocity definition, your velocity frame, and the time to the set of that source, what receiver. So all this stuff is, again, covered in the Cleo window. That is a bit easier to read, but this is good to have just to check, because it's always good to double check everything. And then we have down here, I don't know if I can see it. Try to move stuff. There we go. You have this button that says Command Console. So that is a sort of IPython-esque place for putting in line by line. I wouldn't recommend ever really using this. Everything should be defined in your scheduling block, but more experienced users of the GBT may use that. And so I mentioned earlier these observation states on the side. Let me go ahead and go to my online monitor mode. So here you can see the observation state right now. A scheduling block is executing. It could say idle, it could say activating. So that's what the telescope is doing. Right now, the Gbt state is running, and the Gbt status is warning. I'm gonna let you know right now that is pretty much always the case. It almost always says warning. And if you're ever concerned about that, you can look at the Gbt status Cleo window. It'll say where you're seeing that warning. And if you're super concerned, you can go ahead and talk to the operator about it, and they'll know exactly what's going on.
In all honesty, I'd be more concerned if it didn't say that there was some kind of error, because
and something's probably not connected properly. And so that's pretty much all of those 3 tabs for Astrid. And again, up here you have your normal windows you would normally have. So over here for a new window, these will open up, but it won't open up a full new Astrid. It'll open up sort of small pieces. So like the data display, Gbt status, and stuff like that. You can, again, real-time mode, it's important to remember where this is. And then you have your normal edit, view, tools. So the one you really have to worry about is in data display, the tools, because that'll give you all the options. But that's most of Astrid. A lot of the stuff is connected to Cleo, which is why our next talk in this portion is going to be Cleo. But do we have any more questions about Astrid itself? I can't.
There was one question that people are talking about in the chat about why is pointing at higher frequencies generally more difficult than at lower frequencies?
Sure. Amber, do you want to answer that one, or do you want me to?
So your wavelength, my brain just failed there, is shorter, and your beam is going to be a lot smaller. So when you're pointing at a higher frequency, if your source is, you can all see me, right? I think so, my video. So if your source is this big and you're doing L-band's beam might be this big. So, you know, if you're off by a little bit, you're still going to see it. But like the beam for W-band is going to be like that big. So if you're off by several arc seconds or whatever, you're going to actually not be able to see your source because the beam is smaller. So you need to be more precise because you want to make sure you're actually seeing your source. And because the beam's smaller, it can also be more affected by like wind and like the telescope being moved and stuff like that. So you just need to be, you just have essentially you're looking at something, you're using a smaller beam.
Sometimes at high frequencies, we will build up focus or pointing corrections from lower frequencies. Like we might point at 10 gigahertz first, and then go to Argus to point at 90 gigahertz or so. So we get that initial correction and then can correct further at higher frequencies.
And most of the time when you're looking at your pointing, it'll be pretty obvious if something's going wrong. But again, that comes with experience. So, all right, I'll go ahead and stop my share and then allow Amber to take control.
Whoop. I don't know if you all just saw that, but sure. Okay, good. No, yeah, there might have been a video game running in the background. All right, so you guys can see my screen now though, right? Okay. So just like how you opened Astrid, you're going to open Cleo by typing Cleo. I was doing and. I hit enter too many times. So what will come up when you type in Cleo is this window, which is called the Cleo launcher. You can also open, essentially Cleo is a bunch of little like GUI apps put together. Cleo actually stands for Computer Library for Engineers and Operators. Cleo is also the name of the person who developed this, their cat. So they might have picked the name and then came up with the acronym that goes with it. But Cleo is your main way of monitoring the telescope. Astrid's how you control it, and Cleo is how you monitor what you're doing. So you can click here or on the launch button, and you'll get a drop-down menu like this. And so you'll see there's a whole list of things here, and I'll go over basically the main ones. So the window that Brenne had already mentioned is called the status window. And this is the window that I would always suggest opening. It is, it essentially is going to let you see everything that you could see in that Astrid window she showed you, but it's going to be much easier to see, and it's going to be more visually, I don't know, it looks prettier. Let's just put it that way. So the thing is, it will take a while to open it because it's essentially grabbing like 10 different apps and trying to stick them all into one. So it does take a bit to open, as you can tell. So it has a little progress bar here. It's thinking so hard. There we go. Okay. So this is this Gbt status window. Lagging. Oh gosh. Okay, hold on. Bring it back. Okay. So as you can see up here at the top, I'm going to go over what each part of this is. You see that status and running, like that should be mirroring what you see in Astrid, the thing that Brenne already showed you. But now you'll be able to see, because it says warning, you can actually see in this part right here what is actually causing the warning, or what device is in warning. So this is part of what's called the scan coordinator. So there's all these apps, and the people who use them is usually the operators have 4 windows, since you guys can't see what the Gbt control room looks like. The operators sit inside what's called a horseshoe, and they have 4 monitors that control the Gbt, and so they don't have this screen open, they have every individual screen open, which is just because it's easier for them to see what they need to see, and it gives them more information. But for your purposes, it's easier to just have this window open. So you can see so this is called the scan coordinator, and so essentially what happens is it shows what devices are being used at the current time for that observation. So you can see, oh, there we go. I was like, where's the receiver? So like you can see, this is a prime focus observation. And then the warning. So the reason we always say that even if it's in warning, you probably don't have to worry, is there's a message button at the bottom here. And this message window here will show you what might be causing. So you can see the prime focus one has a warning, and this has a warning, and says this is something the operator knows about and is aware, and isn't actually a problem. So the other warning here is saying that because the temperature has dropped below 17 degrees Fahrenheit, which I'm going to change this because I unfortunately can't read the other way around. Okay. They shouldn't be in half rate mode. they might have just not changed it back yet. But when the temperature drops below 17 degrees Fahrenheit, we have to put the GBT into half rate mode because the oil and the grease will start to seize up at those low temperatures, and it becomes more of a glue instead of a lubricant. So the telescope moves at half rate, and the operator will tell you when that's happening. More than likely what's happening is that this person started when it was very cold, and rather than take the time to stop and allow them to change the rate, they're just continuing to go. They're probably, I'm going to guess it's pulsars or something. Yeah, it's probably just observing pulsar timing. So the next set of windows over here are essentially also part of the scan coordinator, but it gives you, you can see the LST, UTC. So once you've started and once you've actually started scanning, you'll see these things will all update. So you'll see we can see what source they're on, what's their scan number. You can see the project ID, what's the switching master for the noise diode, the start time. There's a count. So countdown is essentially, so in this window over here, I guess I should point out, is you see everything says running right now. So there's a couple different things you'll see in that window. So you'll always see these, but these will be the ones that will change, and they can say anything from ready to idle to activating to running, aborting. And so running and all being green is the state you usually want to see it in. But when they're when they're not actually running and they're just setting themselves up, you'll see this little countdown here, which will tell you how long you have before your scan is going to start. And then remaining is the amount of time that is remaining in your scan. You can see who the observer is. This is an operator run project, so the operator is actually running it. Because it's pulsar, it doesn't necessarily know what the observation type is. It's telling you essentially all the information that you've put into your Astrid script. You can see your rest frequency and your frame and everything like that. So then below that is kind of a combination of the weather app and essentially where all your corrections go, which is your antenna control app actually. So you can see here, this block will tell you what the telescope is doing. So right now it's on source, so that means it's following where it has to go. If you're putting the boom in and out, it will say boom retracting or boom extending, or it will say slewing if it's moving to where it needs to go. So this will or it will give you a countdown time. If it's slewing and it's going to a certain source, and it's going to take it 30 seconds. It's going to say 30 seconds until source. The little box next to it, if that lights up red, that means somebody has hit an e-stop physically on the GBT. So it's not very likely you're ever going to see that light up. And the operator has a much brighter warning if that happens. So they're more likely to see it. So I wouldn't be concerned about that. And I mean, if it's on, you should definitely ask the operator what's going on, but that's more than likely you're never going to see that actually turn on. So the corrections that Brent talked about in Astrid, here's where they'll show up. You can see the as correction and the L correction. Excuse me. And then there's the focus correction would be down here. And then there's a pointing model and all these type of things that the operator has already set up for you in the background. But something that's relevant is this kind of L-shaped thing here. This is the part of the weather app. And the weather app is, so again, remember this thing was built for operators and engineers. So you have to remember that the operators care about the telescope, not about the sky. So this is actually a view of looking down onto the telescope. We have another view that I'll show you shortly that will be what you want to actually see. But this is essentially just shows them like wind direction and where the telescope is, where the sun is, where it's moving, and everything like that. It shows them the temperature here, or you can see the temperature here. And then here, this is the wind speed. And this one is probably the important one for most people. So you'll see I have it set to miles per hour. So there's a little tab here. You can change it to whatever you want. It will default to, I believe, meters per second and Celsius is what it defaults to. But I change it because, yeah. So you'll see there's colors here. So right now, because we're at prime focus, the beam is so large, there's really no wind. There's really no issue with the wind because the GBT can't be blown around by wind big enough with a big enough, offset to actually affect the beam. So there's this orange marker here at about 35 and then a red one at 40. And so what this actually means is that at 35 degrees, if you have continual gusts, at 35. The operator, for safety reasons that are not because your data is going to be affected, but actually just safety reasons for the telescope itself, they're going to start to consider possibly slowing the telescope. And if wind speeds hit 40, they're going to definitely stop the telescope. Sometimes when you're doing a higher frequency receiver, you'll see a bright yellow bar that can go down all the way down to like 5 miles per hour. That means that you might want to make sure you're checking your data, because that beam is small enough that the wind speed might actually be affecting your data and causing, as I said earlier, the telescope to shift enough that you might not be on your source. So you want to definitely check your data while you're doing that. And then down here is the if you're doing high frequency, these will usually be highlighted green. So those are for dynamic corrections, which again, that's essentially enabling the active surface. Over here is essentially your this is just seeing where the telescope is pointing. So you can change this. It defaults to encoder because that's what the operator is using. So it shows you where the telescope is or where it's been commanded to. And then it tells you how fast it's moving, etc. You can change it to be whatever you want it to be. This doesn't affect the operator at all. So you can check to make sure your source is where it should be. But encoder is where it's going to default to. And then down here, there's essentially device and IF manager. They're just going to show you your path that you're using to essentially, so you can see your saying here's the LO frequencies, here's the prime focus, and then you're using, this person's using OD1 and OD3, which is optical driver 1 and optical driver 3. And then it shows you your converter rack, and essentially you can follow your path, your data stream essentially by looking at this. And these are kind of quick checks too. If you see a fault and you don't quite understand, look to see these values highlight in red if something's very wrong. Usually the operator will catch this beforehand though. So that is a quick overview of status. And when you do your observations, the your observer, so your project friend, will help you. You'll all have that screen open and they can go into more detail with that. Cleo launcher, come. Or don't, or froze. I think my computer just froze. I see you're all moving, so I know, oh, wait. Aha. Ta-da, magic. And so a quick thing I'm going to say about, I showed you the messages earlier, and I just always want to show people this because it's good to know. So so I remember I said this is a conglomeration of a bunch of different apps. The actual message app, as you can see, this is what the operators are actually saying. They actually have device selected too. So you'll see something that will say like antenna is in warning, and you're like, well, why? I don't want the antenna to be in warning. That's not good. In the status window, that is showing you only the faults that apply to your current observation. However, there are 1,000 other components on the telescope that are not affected by, that are not part of your observation. They're part of, you can see I have Mustang here, or there's the KFPA or Argus. And the fact that these exist are giving faults to the telescope, but they're not faults that affect you. So this is why if you're confused, you can always ask the operator, but you could see these are all the faults that the operators are seeing. And as you saw on our screen, we saw 3 of them, because none of these are actually affecting the current prime focus observation. Like they don't care about the cryogenic faults on X-band receiver. But those will most likely clear once the X-band receiver is the chosen receiver. So you can always open this if you're curious. This is what the operator's seeing. And if you really want to know what the fault stands for, you can look here. But it's just good to note that, you're only seeing the faults that are, for you. There's actually a lot of other things that are, going on, and that if the operator is not concerned, it's because they don't think that it's not going to bother your observation. All right. I'm going to go to observer tools. So observer tools, the other one that is important is your sky view and your scheduler. Blech. So it opens up, it looks like this. And essentially this is the way that you can check your sources on the sky, and you can see, you can load your own catalogs into this, and it will show you where your sources are and stuff. So right now it's open in scheduler mode. So if you're observing at a certain time and you want to know what the source sky is going to look like at that time, you could change it to be, let's just say we're going to observe tonight at 11:30. And then you type in your date and your time. This is all in UT. You can also do this for telescope position and stuff like that. But usually you're just going to be putting in your time. And so then now it changes the sky to be what the sky will look like at that time. And then you can go, there's a button up here called catalogs. It pops this up. And then you go to add catalogs. So now here are all the pre-existing ones that we've created. And Brenne mentioned here's the Flux Cow one. They all have colors next to them. You can go in if you need to, and you can change the color so they're easier for you to see. But then there's this option here called Add User Catalog. So you can go in, and I'm not sure if I'm going to have a catalog that works because I do radar observations, and those are not normal catalogs. Oh, maybe. So now it has my catalog in, and I will just change it, whatever that color is. You click Apply. And okay. So now it's showing the sources that were actually in my catalog that I entered and saved, which of course are not actually up, because I just picked that one at random. But see, I can change it by increments by hour. So let's see if I can. There we go. So there are my sources now, and I can see when they're going to rise and when they're going to set. You can see where they are in the sky. And so also, right now it's just sitting. This is the telescope's position. It's just sitting there because you're in schedule mode. If you go to real time mode, it has now changed the sky to what it is currently doing and where the telescope currently is. So the telescope is actually pointed here. And then this is the path. This black line is the path that your source is going to take. So you can see it's going, when it gets to here, it's going to set. So essentially this is rise and this is set. And when you hover over this, as you can see down in the corner, I can't really point to it with my pointer because when I move the pointer, it'll go away. But in the bottom corner, there's anywhere you hover on, it's going to give you where you're pointing. You have azimuth and elevation, your galactic latitude, longitude, your right ascension and declination. And if you have a specific source, which of course using Saturn planets is not great, but it'll tell you up at the top where it says source, it will say, here's your source. And then it should also tell you the brightness in, I believe in Jansky's, or was it millijansky's? I don't remember. In one of those two, it will tell you how what your brightness is. So actually, let me so if I pick the flux calibrator, or flux catalog, sorry, and tell it to input, now you see there's a lot of things there. So when you're trying to pick one, like let's say, I don't know, you're doing something around here, or this is your source. You can actually tell it if you want. If I hover over that, you can see, of course, that one doesn't show me one because, so this 3C249 has a brightness of 2.48. So you can actually go over here and change that and say you don't want anything that is less than 5 Janskys. And so as you notice, some of them have disappeared. You can go to 10, as I get higher. So you can essentially set a range of like, I want something that's this bright. I don't want something that's, not very bright at all. So you can go ahead and go in and change that. You can also take out all the labels and stuff if you don't really want them in there. And then again, sorry, down here you can actually choose your position instead of a time, if you really want. I'm trying to remember. So also, I guess it's good to note that right in here, the telescope cannot go below 5 degrees elevation, and it does not go technically above 81. It will kind of start to get mad at you, but I think it's actually will let you go up to 89. So once the telescope hits this, which is what we call the keyhole, it can no longer track, because it's spinning, it can no longer track at the speed that the sky is moving, because obviously the sky is moving very fast up there. So we don't let you don't want to observe inside the keyhole, and actually in most cases it's not going to let you. But like right now, observing Cygnus A would be a very bad idea because it's essentially moving faster than the telescope can follow it. So you want to try to make sure you stay out of the keyhole. And then this black ring around the outside is essentially 5 degrees elevation. So if, as you can see, their source is off here, which is saying they're not in the telescope's field of view at whatever time I have it set to here. All right. server tools. All right. Soapbox time. I'm sorry, Will. I'm trying to finish up here, but I have to do my soapbox. So this is talk and draw. Talk and draw is how you are going to communicate with the operator. What I probably didn't tell you because I didn't think about it was that, so I'm a data analyst now, but I used to be a telescope operator. So I used to be the person that was talking to you when you would start to observe. So I have a soapbox for you. This talk and draw has an alarm on it. Every time you type something or log in or log out, there's a horn honk that occurs in the control room. And unfortunately, because we're doing this remotely, you cannot hear it. Usually I will make the operator do it once you're in there so that you can hear it. Let me just let him know what's going on. So, so essentially you log in, as you can see, Tyler is one of our operators. He knows who I am. So he knew when I logged in who I was. But when they log in, what will happen is they'll usually say, you know, hey, Tyler here, you know, and then you just say, you know, I'm this person here for this observation. However, like I said, every time you type something, every time you log in, every time you log out, a horn honks in the control room. So this is to get the operator's attention because they're sitting there alone for 12, they have 12-hour shifts. So they work from 7 a.m. to 7 p.m. or 7 p.m. to 7 a.m. And that's a long shift. And they're not always staring right at the computer screen. So this horn honk is designed to let them know when you need their attention. That being said, my soapbox is do not have a private conversation in this window because I have sat there at 2 o'clock in the morning and Joe is sitting there saying, hey, Steve, how's your day? My day's great. How was your day? How are your observations? Every single time you hit that enter button, the operator hears honk, 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 honk. It's not great. It also becomes the, as I call it, the boy who cried wolf effect. If you keep having a conversation, they're going to start to ignore you or ignore your horn honks because they're like, oh, well, they're just having a conversation, whatever. And then when you actually need them, they're not going to respond. You're going to have to call them. So there is this neat little option called create a new group. You can create a new group, which has now opened a separate tab. So you still have the operators tab here that you can still talk to them. Because anything affecting the telescope, you should be telling the operator. But if you're just like, you logged in, actually, I used Steve, and I didn't actually mean to because there was someone named Steve logged in. But like if I wanted to talk to Steve, this is Steve Croft, I could actually go in. Now I'm in this new tab and it says edit membership. So I can actually go in and drag another person who's in the other window into here, and then I can have a private conversation with them, and it's not honking at the operator anymore. The operator is no longer noticing a horn honk, and you can have a private conversation with them and not make the operator hate you, which is a bad plan. There's this button here called Get Attention. That button should not exist, and if you ever touch that, the operators will seriously dislike you. So what that button does is it just forces the horn honk to happen without you typing anything. And the operators will get a message that says, someone is trying to get your attention. Every time you type, they're going to see that. So you don't ever need to actually push the get attention button. It's just an annoying way to make the horn go off. There are people who use it and it drives the operators insane. The other thing I'm going to note real quick is that the operators, many of them are younger in age, but some of them are a little bit older and do the hunt and peck method of typing. So if you ask them a question and they don't answer you right away, they're either number one, they don't type super fast because some of them do this, or they're trying to fix your problem for you, and therefore they're taking away time if they have to go back and type to you every time they're doing something. So I would say give them time. They also are allowed to leave to go to the bathroom. So if they don't answer you right away, try to give them as much time as you can. You can always call them if you would like, but they might not answer you right that second because they are actually allowed to like leave the room and go to the bathroom and do stuff like that. I will show the last feature, which is, it is called Talk and Draw. You do have the ability to draw in this window. My short story that I will tell is that when I was an operator, I was observing with one of my friends was observing with another person. And he knew my whole speech about don't have a conversation and talk and draw. And suddenly all I see happening in the windows is H, A, N, Q. And I'm like, oh my gosh, what is he doing? He's trying to kill me. And so I said, Dave, what are you doing? He says, open the draw window. Him and his collaborator were playing hangman in the draw window. So I joined in on that, and I was less annoyed after that fact. But you can actually draw things. Nobody usually ever does, except for just to be playful. But that's my kind of my quick little story about about don't annoy the operators. So I think there's also 2 buttons here, sorry, that will say auto sound. Auto sound doesn't do anything for you. VNC, since you're using VNC doesn't support sound. So the operators hear the sound because they're sitting at the actual computer that they're using. Since you're VNC'd in, you can't actually hear a sound, but you can, however, pick this option, which is auto raise, which means that when something is typed into talk and draw, it will actually pull this window front so you see it, because a lot of times this will get pushed to the back and you might not notice it. And actually there's one last thing I should show you quick. And yeah, I guess the other thing I'll just mention real quick is under these operators tools, there's something called the gateway, which you'll learn about if you haven't already, is essentially how the operator gives you control. I believe Brenne mentioned it in her talk, or her part of the talk, where that's how they give you access. And so when you'll probably hear them use terms like, I'm putting you in the gateway, or you're in the gateway, go ahead. That's just their way of giving you control of the telescope. And you can't actually open that. I mean, I can, because I know the password to it. But if you try to open it, it's just going to yell at you and ask you for a password. But the last thing that is probably good to know is there's this thing called Cleo container. Cleo container is essentially a browser-esque type thing, but it allows you to launch all of those apps I showed you inside one window. So instead of having like 20 apps all over my screen, I can open that, and then I can open, I don't know, let's say I want to open the prime focus. I can just start opening these things, and they are going to open, they're all going to open in this window, and they're going to give me tabs. And I can actually just click through those, and you can actually resize this as well, which you can actually do. Some Cleo windows will not allow you to resize them, but you can resize everything in the Cleo container. The one stipulation is the status window is very process heavy. Don't ever try to open that in the Cleo container. I always open that separately. It essentially will just crash this thing because it uses so much process. I don't even know if it will even open in that. All right, we're gonna make that go away. Oh, it's probably, yeah, it's asking me for the password. That's why that was still up. But yeah, so open the status window separately, but everything else you need, you can pretty much open in this Cleo container, and then you can click through them. You can even open talk and draw on this as well. So you can just, use this instead of trying to have 20 windows open plus Astrid plus, whatever, all your data processing stuff. All right. Cleo launcher. Let me just make sure that, I think that was everything. There's miscellaneous tools, which you'll never have to use. And you can always open any of these that you want to open and look at them. You're more than welcome to do that. Unless you have control, you're not going to be able to change anything that would damage the telescope. If I open the actual scan coordinator, I cannot change anything in here. Actually, I guess I could have showed you right here. I can't scan coordinator. If I wanted, so there's these lock buttons, and if I try to click unlock, it's going to say you cannot do that. You need gateway privileges. So you essentially can't, in this case, you can't screw with anybody else's observations unless you're in the gateway. Whereas like in Astrid, you can edit scripts and stuff like that. And if you get an error like that, then you just need to ask the operator to put you in the gateway. And they might sometimes ask you what computer you're on. When you're observing, you should always be on Titanium and Aerial. I am not, because I'm not observing. You should only use Titanium and Aerial when you're observing. But the operator's computer is Victor. Of course, none of the people logged in right now are on the proper computer. But so they can also scroll over your name sometimes and see what computer you're on. So you can see there, it says user, and then it says the host. But in some cases, Prospero is the default computer. So Steve is probably logged in on Prospero, but has SSH'd into Aerial or Titania, which it won't show. So in this case, Steve would have logged in and said, hey, Steve here, I'm on Aerial. I'm an Aerial. And then the operator knows to be put in the gateway put them in on the gateway using Aerial. Brenne, is there anything else in Talk and Draw that you think I missed?
Another note is if you have those side conversations you should remember to check the all users conversation pretty frequently. It will flash slightly if something's been said in the all users, but if you're observing and you're talking with people, it's good to just make sure that you're going back to all users. Otherwise, the operator has to use the get attention button for you. So
What? They've done that?
I've seen it.
Also, don't put the operators in a side conversation. Like, I mean, I guess if you know them personally and you want to talk to them, that's great, but don't like add them to your high conversation so that, you know, I don't know why you would do this, but apparently this has happened recently. Because we want to keep them aware of what's going on in this all users conversation and not distract them with other things.
And make sure to log out when you're done. That's one of the more important things too, because otherwise we get a whole collection of people on the side.
Oh gosh, I can't type. So I've done that, it honked, and then when I hit quit or X, it now also honked again. So that is my soapbox, and you'll hear me say this like 8 more times, especially if you're in my group. I'm sorry, you're gonna hear me talk about how you should not make the operator, how operators should be your friend. You want the operator to be your friend, trust me. All right, oh, there's some questions, I believe.
I think we've covered all the questions in the chat.
I wasn't reading them as I was going, so, all right. Anything else? Well, is there anything you can think of that I should have mentioned in Cleo that I did not?
I don't think so. Everyone will have their own hands-on time with the system as well. So there's a lot of information to digest about how to go about controlling the GBT, but hopefully it'll be clearer after you've had your own one-on-one time with the telescope.
I'm just not sharing them.
All right, thank you both, Amber and Brenne. Right now we're up against a break, and we will try to start back right on time at noon Eastern, so in about 20 minutes. And the last 3 sessions for today are more showing you how to use the Greenbank computing environment, how to go about using our data reduction tools, and then the last thing will be a connections workshop that shows you how to use your credentials to log into the observatory interface. So thank you very much.